Good evening, everyone. Welcome to this Technitude on data analysis using Python with Numpy and Pandas. I hope you're all doing well, and without much delay, let's get started. So, what is exactly data analysis? It basically involves the process of inspecting, cleaning, and also transforming data before we can create models or draw various interpretations from it. It is one of the most important processes to be done when we are dealing with data. Now, for data analysis, one of the most common technologies which we use, which you will hear about, is Python. Now, Python for data analysis involves various different terms. Some of the first few you will hear is module, package, library. Now, there are differences between all of these. Module can be thought of as a Python file, a simple Python file, which can be imported. It can be also defined by a system. It can be built in. It can be user defined as well. Now, when we come to packages, they can be thought of as folders containing different modules. Let's say you have a bunch of modules, or you have built-in modules which have the same meaning or they interact with one another. So you put them in one folder, calling it the package. Now, based on what we hear about data and everything, these few modules or one or two packages may not be enough. We may need tens or maybe 15, 20 packages at one go. So we can't download or import 20 packages. We can't have 20 lines of import. That's why we move on to libraries. Basically, libraries are either collections of modules or packages, whichever way you sort them in. Now, there are more than 100,000 libraries we know of. Some common ones, like the ones which we will be using today, are Numpy, Pandas. Along with that, we have Matplotlib and Seaborn, which we will be covering in the next Technitude. We have OpenCV, TensorFlow, Keras, and various other similar libraries. Now, moving on to Numpy, the first library. Now, what is Numpy? Basically, Numpy can be thought of as an array, but it's not just a simple array, or it's not simple Python list. It is way more faster. Along with that, it occupies less space than Python lists, and also has many built-in math functions, which helps us in computing various stuff, mainly involving data. Then we have the library called Pandas. Now, Pandas is mainly used as a data manipulator and is also used in data analysis. We can import files, CSV files, or various different files, including SQL, and we can work on them. We can develop various tables from it, various derivations from it, which will in turn help us in drawing various conclusions. This was a short theoretical section. Now we start with the main section, which is the hands-on session for Numpy and Pandas. So I will begin with sharing my screen, where you can code along with me. Now there are a few steps which I will show you before we can actually start coding. I hope my screen is visible.
Yes, Binayak, it is visible.
Thanks, Akshat. Thanks, Anupam. Now, the first thing is we will be coding today on Google Collab. Now, the link to this site will be shared in the chat. Now, this is basically an online editor where you can easily code. You don't need to install or download anything beforehand. Most of it is installed. The only thing which we will be putting in will be the CSV files. Now, for the CSV files, we have you in store, and we will be sharing the Drive link as well as the Google Collab links. Okay, let me just open up. See, here we have the Collab research Google, and then we have the Drive folder. If you are able to open the Drive folder, just say yes in the chat box. We'll move on after that, giving you 2 minutes. Great. Now, once you are in the Drive link, you will notice car sales.csv. Now just right click and download it right here. You can download it anywhere. Just make sure you can access it in the local directory. Great. There are quite a number of people who have been able to access it. And also open collab.research.google.com. Here you will see a few options like the recent files which you might have opened, a few example files maybe. And along with that, on the bottom right, there is new notebook. Now click on new notebook right here. And you should see this workspace. Now, if you are able to open the Google Colab workspace, just tell me if you are facing any problems. You can unmute as well. It's not a problem. You can unmute and tell us if you are facing any problems. Okay, so right now we have the CSV file downloaded in our local directory, and we have an untitled IPYNB is Python notebook. If you are ever coding offline after this technitude, or when you go get into more advanced data analysis, you will be working on your offline local editors. There you will either be using this, or you can directly use .py files, Python files. This is basically a Jupyter notebook where we will be coding today. We have reshared the link in case you guys have missed. Those have just joined just now. We will be coding here collab.research.google.com, and in this drive, yeah, sure, Akshat, you can use VS Code. Make sure you put the CSV file in the same directory where you are opening your Python file so that you can access it. Okay. Right now, we won't be using the CSV file which we have loaded. Let's just start with Numpy first. A few basic commands, and then we'll move on to Pandas, where we will be using the file. Now, on my screen, you can see the first command, import numpy as np. Now, this is what I was saying, importing. Our numpy is a library. We need to import it. Now, this is an online editor. You don't need to download the numpy library to use it. You can just directly start with import numpy as np. Now, why np? Because, well, I don't want to keep writing numpy in all the commands, so I shortened it to np. So this is like a nickname. Import numpy as np. That's the nickname. And if you click this cell like this, let me just copy paste it. This is the first command which we have. Okay. Grammatic. Okay, your question is answered. Okay. So when you open your untitled file like this, in the first cell, which is automatically added, add this line, import numpy as np. Once you import it, you will see this play button. This is basically the run button here. So just click it, or you can just press Control Enter to run it. After you're done with it, you will see this small arrow here. It means it has run properly. There are no errors. Now, this will not give any output, so it will just show you that it has been successful. Now let's just have a standard for loop like so. Now, anyone here who is new to programming and has no idea about for loops or any kind of loops, just to make sure before we start. You cannot differentiate. Yeah. So a module can be thought of as a Python file, an individual Python file, which you can use, import in your own code. Libraries are, let's come to package first. So packages are like folders which contain these modules, and are again, they can be imported into your code if you have them locally. And since we have several different packages and some more, there are packages which are related to each other and are used together, like we have several packages inside one. So that's why we arrange them all into one library. They are like collections of modules and packages together. And right now we are using the NumPy. That's a library. Okay. Anyone who is new to loops, coding in general, but I will explain for loop. Okay, I'm guessing there aren't any. Okay, so in a for loop, we run something like this, where we put I in range. So similar to that, we are actually declaring a list, just like so. Now that thing with Jupyter notebooks is that you don't need to explicitly write print L. You can, if you just write L, the variable, it prints the whole thing. Like so, it printed from 0 to 1000. The alternative being this. Here you have put L equal to range 1000, and then you're printing parts of L, each element. Another thing I wanted to show this L equal to I for I in range 1000. Now what this does is, for in range 1000 is the for loop, but in every iteration it adds I into this L, creating a list from 0 to 999. So like so. Now this imports is another thing which we have imported just to show you the size 9032. Now let's do the same for NumPy. Here for NumPy, remember I imported it as NP. Now a range is basically a function which creates NumPy as a, it basically replaces this for loop, the need for the for loop, as a range from 0 to 999. Now let's print the size of this. You can comment this out. Even if you don't comment this out, it doesn't matter because it will run the last line. Now let me comment out so that it runs this. Control Enter to run it. That's a keyboard shortcut. That's item size. Now we want the total size. And notice this is quite smaller than the list, which is one thing which we said, that it occupies lesser space. Now let's see how operations on individual elements go by in NumPy arrays. Now, if we have lists, what we do is we have the list created. Then for every iteration, we add I in range length of L, li plus equal to 2. So that adds to it. It has internal scrolling, so you can scroll up and see it has changed. Now you will see this option where you can remove this output because it's a very long output. We don't want to scroll that much. Let's remove the output. This is another method which we use basically for I in L like this. Then we are basically overwriting it with I plus 2. Now for numpy arrays, what we would do is just write, let's say we have it here. Now what happens is, see, 2. Now what's the advantage? You just had one cell line. You didn't have to put the loop or anything. Okay, I will just pause here and ask you guys, the code which I'm writing, is the font big enough, or do you want me to zoom in? Anyone has a problem, please do tell. Okay. Fine, that's great. So you see just one line. Let me just remove this output right here. Now I mentioned that we have inbuilt, we have a few inbuilt mathematical functions. Now for that, let's just try with lists first. What happens with lists? Now let me just run this line first. Okay. Yeah. So we will be using a new function just for the sake of showing you how it works. That's zip. Zip basically assigns one element of L1 with another element, with the equivalent element of L2. Basically the first element and the first element, second with the second, like this. Now what we do is we want the dot product, like you might have done in vectors where we have the dot product. So I am multiplying these. I have made it into a zip, and I am multiplying these and adding it to a dot. This is basically the dot product. And comment this, comment this. Now this is the dot product which we got of L1 and L2. Now how about we use numpy arrays? This is how it is. See, just 3 lines. Declaring is 2 lines like before, and just np dot dot. Last but not the least, we mentioned that numpy is faster, but there is one exception to this, where l.append is actually faster than n.append. Now, can any of you make a guess why this exception might happen? Any wild guess or anything you wish to say? This is one exception, but why do you think it is? Okay, let me tell you. The thing is, when you have n.append, which is the numpy version, when you are appending from a numpy array, what it does, it creates a new numpy array. It creates a new array, so that extra time makes it slower than l.append. In l.append, it just does in place appending. What it does, it doesn't create a copy from within, it just appends to the original one. That's why it's faster. This is one exception you might want to remember. If ever you are asked, or if it's a trivia anywhere, you might be able to use this knowledge. So this is a brief introduction to NumPy. So in data analysis, you will not be using NumPy directly. In fact, you will be using Pandas, and in Pandas, there are a few commands, there are few processes which we do where you will be using NumPy logic. You might notice when we start with pandas is that a few outputs have the data type of NumPy arrays. They may have, they actually are sort of integrated. NumPy is sort of integrated in it. So we directly don't use NumPys. When you have go to an advanced level, you may not really hear about NumPys, but you will definitely hear about pandas, and pandas use NumPy. So, and by the way, when you use pandas and when you're using NumPy logic, you actually don't have to import NumPy unless you're using something as direct as like this np.array. If you're using normal instructions, which we will start, you don't actually need to import. That's one thing. Now, before I start with pandas, any more doubts regarding NumPy? Kamlesh had asked a doubt. Okay, it's solved. Anyone has doubts with NumPy or anything before that? Let's clear that before we move on to pandas. You can put it up in the chat. You can unmute yourself. Okay, so I'm guessing there are no doubts. So let's start with pandas. Now, I created a new notebook. You may not want, you can continue like below this. So the thing is, we have, you can just add here code, text, code, basically code, and just start with it. Or you go back here, just click here. Let me just show it. Just click here, you will go back to Google Drive. You can start a new Collab from here, or just go to that link and then create a new notebook. It's your wish, whichever is easy for you. Those who are using VS Code, you can copy from, you can just start from there or create a new file. So for this, we will be mainly using pandas. So again, we have a nickname, import pandas as PD. Again, a nickname. You can, this is like very common. It doesn't have to be PD always. It can be anything. But this is the most common thing, pandas PD, and numpy np, just like that. So we run this. Now, one more keyboard shortcut which I would like to tell you. We had Control Enter for running it. Now, if you have Shift Enter, what it will do is it will run it and then go to the next tab like this. And if you don't have a new tab, then it will just create one and go there. And if I just hover somewhere else, you will see a 2 right here. If I hover, it will go away, but unless if you see a 2. Basically, what happened is when I ran it the first time, it was 1, and then I ran it again, so it became 2. It basically shows the order. Suppose you run it 10 times, it will show 10, and then if you run the next tab, it will show 11. So it helps you to order it. Suppose you don't follow the usual order, you run this first and then this. So it will help you to organize that which one did I run first or which one did I run last. Okay, let me just run this and then I will explain the output. Okay, and I'm just copying and pasting this. Import pandas as PD and this first tab. Is the first set of codes which we will be doing. Now, what is this? We did numpy.array, but let me just explain this, what this line is. Now, we declared about how we have Python list and how we have numpy array. So this is nothing but numpy array. The way of declaring it is, let me just increase nonetheless. So what we have here is np.array, then first bracket, and then with the third bracket we have one, two, three, all the elements, whichever element you want to add. Now the thing is, there has to be numerical. In lists, you can have various different sizes. Which suppose you have the first is a character, then it is a string, and then it is a number. Anything. It doesn't really specify which type you want. But here you need to make sure that these are numbers, all of them. This is also a reason why numpy arrays are smaller, because lists have to store what the data type. You're not declaring the data type specifically, and you have mixed data type, so it needs to store that this is a character, this is an object, in like that. So number doesn't have to do that, because it knows that, okay, these are numbers, and if it is a number, it will just put the blame on you by giving you an error. So we ran this, and then we have S1. S1 is just a variable series. Now series, we have Panda series. What it does is it creates something like this. We have 1, 2, 3, 4, 5, 6 as the data, and this is the default index. Okay, we can have different indexes. I will show you later. Now this is just like having a list, but it's more of like a dictionary, Python dictionary, if you might have heard of. It's more of Python dictionary where this is a key and this is a value, key value pairs. Now this is in Pandas. Now you will see why we have series and all these terms later. Now let me just comment this out, and instead of numpy arrays we have, let's put lists. Now let's see what happens. Control enter again to run it. I put different numbers so that you can differentiate. That's a different output. See, it's the same thing. So what did we see? Series can take in numpy arrays, it can take in lists. Now what if I don't want 0, 1, 2, 3, 4, 5? I want something else. I want some other index. So let me just try with this. I'll run it and then I'll explain. Okay. Now notice this is li, just it's a list index. I just put it just like that. And we have A, B, C, D, E, F. We have 6 numbers. So I put 6. Now this is the new parameter. I commented out, since the fact that I ran it is why it is already stored. Now if you're on offline or local editors, you should actually not comment this. Notebook, it doesn't matter because it's already stored as a local variable. Now just uncomment this. Those are working on VS Code or anywhere else. Now what we did is n is the data as before, and index equal to li. So basically what we showed is that index takes in a list which gives the index, see, A, B, C, D, E, F. So that's how you had user defined index of sorts. Now I can have something, I can directly put it here also. Okay, instead of having it here, let's just put the whole thing. Remember to put the brackets also, because it takes a list, so it needs to have that list. See, it's running the same way. Let's go back. Okay. Remember, if you want to save these files, if you want to keep these, anyways, don't worry, we will be sharing these. We have WhatsApp groups, pressure groups, where we will be sharing the code, we will be sharing the PPT. We have more CSV files which we will be sharing right here, the PPT, everything we will be sharing in the fresher groups. To make sure you join them. They were shared before, we will share them again, the 2 links. There's a Telegram group, there's a WhatsApp group. Make sure you join them. You can also get the cheat sheet which we will be sharing within 24 hours after this Technitude. So we are done with this part. Now that's series. Now what are data frames? Now data frames in layman terms, think it of like very similar to series, but it is more of like a table, because you can have more than one columns. You can have various different functions to it. We'll go to them slowly. Now let me just run the first one. Okay. Yeah. So I just put mine first. Let's just put a few videos. So you see, all remember that the default are most of the time the defaults are 0, 1, 2, and 0. Now the columns are not named, it's just the index 0, it starts with 0, as you know, and the rows also starting with 0. The names are also starting with 0. What if I want some other I want some other column names? Obviously we won't have 0 as a column name unless it's very specific to a data type. Let's run this one. Let's see what we get. Okay, sorry. That's okay. Please notice there are two columns here. How I made a Python directive where I put the key as name and then as a list I put the values. These set of values. Basically, name is like the column and branch. The column name when I have written those are the rows. Now since this is the first, these are paired together. Somewhat like that zip which we saw. Let me pause. And okay, this one was for I think. Let's go to that. Okay, first thing to answer that doubt is right. Now the question was, what if Li has less number? Okay, what if Li has less number? Let's see what it does. That's the best way to try things out. Just okay. There is my screen being shared.
Yes, it is.
Yes.
Visible. Okay, thanks. See, this is the error you got. Length of past values is 6. Index implies 5. Now index implies 5, but the past value are 6. So this is what happens if you have a error. It shows value error, and it also explains it. So it's pretty comprehensive. So I hope I answered your question. Himanshu, I hope I answered your question. Okay, let's move on. Where were we? Yeah. So this is using a dictionary. Now let's have something like this. Now this is the where the main thing comes, where we are not using any dictionary, where we are not using any lists. What we are doing is pd.dataframe. Then now let me just type it here step by step. The same thing, pd.dataframe. It will be easier for you. Now we have the first bracket, and then basically like this. This is the general syntax if you want to say. Now what does this have? This basically has these values, each row which we have. Let's say we have for name, year, branch, name, year, branch, name, year, branch, like this. And so these are the members. Now this is a list containing various different lists. That's the basic. And columns like that index which we did in series again takes in lists. So that's what we did. Let's run this. See what happens. Name, year, branch, enact 2020 IT. All right. So this was when we directly use data frames. Now let's say you want to further break it down. Let's say you want to access the the column name list separately. So you declare it separately and then you want to put it inside. So same as before, make a list since it takes, remember. See, personally, I feel it's better if you are ever using this. The best way is to actually specify like something like this, or just write it like list comma columns equal to list, so that you know that okay, I have to put list. I can't just put comma, like I can't have something like this. It will have an error. It will just take name and then put okay, there's an overload and this will return an error. Now let's see what this does. Does it actually do what we expect it to do? Yes, it does. Okay. Now this is basically series and data frame which we introduced. Now let's start working with files. Now before we start working with files, any doubts? Okay. Welcome, Himanshu. Any doubts before we move on to actually working with CSV files? You can write no if you don't have any doubt. Okay, I'm assuming that there are no doubts. So how do we include files? Now when you press here, see by default this might be open to you, table of contents and something like that. Just go here, right here. You will not see car sales, you will see sample data. There's basically there always. You can use these also when if you're trying out anything after this technitude, you can do this. And in fact, after you join the WhatsApp groups, you can actually share what you did, or like if you went ahead or you tried with other CSV files from one which we are going to share, like this their drive. You're welcome, you can share what you did. Okay, so to do that, remember you had downloaded it in a local file like this, car sales. Now just click here and drag it. Now if you notice, this drop files to upload them to session storage comes in. Now I've already dropped them, so I'm not dropping it, but just drop it here. Move will come appear here, just drop it. And if you're working on local files, just make sure, if you're working on VS Code, for example, just make sure that where you are working, where you have saved your Python file, where you have saved your Jupyter notebook, you have the file the same place. Now, if you have successfully imported it, just say dropped. So we're gonna know that you have successfully dropped it right here. If you face any problems, please do tell. Okay, you don't have any doubts, I guess. Okay, let's. So you see it's cars underscore sales. Make sure that C is capital. I mean, when you are writing here and the names match. The car sales.csv, car sales.csv. Now this is where we have the read CSV file. pd.read CSV is actually the function name. Okay, this is a built-in function. If you hover over it, you will see def read CSV file or buffer. Basically, there are many parameters to it. We will just be using this. We don't need to set an index, nothing. Just run this. And df, we don't need to write print df. We just write df. Let's see what happens. You can cross this out so that you have more space to work on. Now see, 0, 1, 2, 3, 4 default row values. These are the index. So this is quite helpful because they give the index by default. So you can use these index. We have manufacturer, we have model, we have sales in thousands. Basically, this is a report. It is very simplified for this session. Data is not usually so, you know, good. Basically, this is not so clean data which we get in real life, but this is specially made so that we can have a smooth session. And since we are not going into advanced data analysis, we will be using such simple files. Here we have, see, notice there is a dot dot dot. Basically, this has 5 and 5, 5 first and 5 last. This is used for sampling. Now df you already ran. You may want to run it again. Print df, if you do just like we do. Now remember, if you're using local editors, you need to have print. You can't just put df. It will not happen. If you put print df, you see something like this, where even the columns, these are shortened. Now this is Jupyter Notebook, so df had this, but in local files we don't have it. So the best thing which we do is a few commands which help us describe the data. First we have df.info. So with df.info, what happens is, remember we have df capitals. If you have different, if you use something like df, if you change it, it will not be the case. You have to use capital D, capital F, or whatever name you give to the file right here. df equal to pd.read.csv. Now df.info didn't actually help us with the columns, but what it did was it included some similar output like print df. So we know that we can either use print df or df.input. Let's try df.describe. Now one thing to note, let me just get done with, yeah. One thing to note is df.info didn't have the parentheses, but this has parentheses. Remember that. You could note that now you could have basically what happens is sometimes you get confused. Info main parentheses, or do we have describe parentheses? Before I continue, just tell me if I'm audible properly. Is my voice breaking quite enough?
No, it is fine.
It's fine. Thank you. Okay, let's continue. Now let's say I don't want to describe the whole thing. Okay, before we move on. Count. What is count? The total number of rows. Basically it's actually more about rows. So we have the count in floats. See, now you may think we have 157 rows, then how come we have 121 only? Why we do have 150? Why is this number different? Because in a table you would expect all of them to have 157 rows. Now the thing is, it is probably when they were taking the report, they don't have it. These are the few very easy to catch errors, which we actually purposely put here because we are actually going to show how to remove them. But these are the one of the first few things you need to notice when you are actually doing data analysis. Remember that it's totally application based, so you need to know why we are using this. So the thing is 157, 121. So there is a very significant number of columns which are not filled. 155, 156. Basically, you could say that the first one is the only one which is fully filled, sales in thousands. So they had the money in mind. While the resale was just 121. Now, 121 doesn't always mean that it was an error. Probably they didn't have a resale for that specific manufacturer, that specific date, that specific row. Didn't have one. So you don't want a 121. We do want 157 column because you might have to calculate various different things. So you can't have it will be biased if you just have 121. So we will replace it. I'll show you how. Before that, let's say you just want to describe one specific column. So what you do is, it's like declaring L, like you have a list L and then you put L0, or you have a dictionary D and then you put the name of the value ABC, name of the key, sorry, and then you get the value. Similarly here, we have DF sales in thousands. Remember, this has to be in quotes if you're using brackets. What it does is just displays this one. D type float is also shown. So you know that this is okay, this is float 64. Now this is one more summarization which you would want to do before you start mingling. 157 cross 16. This is a tuple. This is one more data type in Python. Tuples are another data type basically, and they're immutable. You can't just say tuple. Like if you have a tuple equal to something, then you can't just manipulate it, change the values. In list, you can have L0 equal to something else after you have defined it. This can't be happen. This is basically tuples. Now, what is this 157? 157, you might have guessed, it's the number of rows, maximum number of rows, because we had 121. That's not the thing. 157 is the maximum in the whole table, all the columns included. 16 is the number of columns. Sorry, 157 rows, 16 columns. Right here, can manually count. But this is 16 basically. Manufacturer model, sales in thousands, and all those things. df df.describe we have already done. Can run it again if you want. What is df.sample? Now by the name you might say, okay, we are basically sampling something. We are taking a few examples, random examples. You will see the index 3795. It's again 16. So it's taking various different things. 49, 87. Now if you notice, it's not really in order. It's not taking in order. But what it does is it just takes randomly, so it might go up, down, anywhere. This is just for sampling. If you want to take, you can have sample of, I took 5, you can take 10. That's 10. See? Random 16 is the last smallest, but it's there at the bottom. What is df.head? Right? See, it remember we had 5 what do you say, the 5 rows, and then dot dot dot, then 5 rows again. So this, the top 5 is this one. What if I want 10? First 10. Sampling generates random. I don't want random. I want in the order. The first 10. 0 to 9. 0 to 9 because it's basically kind of starting from 0. So total it's 10. Model, just like we describe sales in 1000, we have column wise description. Let me just run it to show it to you. And like this. Now, the difference is in sales in thousands, it was float 64. So it had various numerical stuff, like we have count, mean, standard deviation, mean. Quartiles you will actually learn right here as a course also, though those who, at least in IT and CSE we have statistics for engineers. Later you will learn about quartiles, where you will learn about the mathematical part. Now statistics is actually quite important. To know about these numbers, it's important to know statistics. Right now we are dealing with analyzing on an overview and in a very limited manner. It's basic. That's why we are not thinking about quartiles right now. Now model is not numerical, so that's why it doesn't have numerical count or anything. It has a count, but it doesn't have any numerical mean or quartiles like we just saw. Count 157, unique 156. Now unique is basically how many unique values you have. Now you may have A, B, B, C. Now unique is ABC, and count is basically the total number you have. So if A, B, B, C, it will be 5, or else unique will be 3. Top is neon because basically top is the one which is most frequent. Now this is a coincidence, only one is repeated, that only once. Now if you had 2-3 repetition, if this was something very less, that means you had 2-3 repetition of the same thing or different things, then you would have the most common, or the ones with one which is repeated the most on top, like top neon. And how, what is the frequency? 2. So it adds up. Like 156 is the unique, and then one extra, this is neon, is extra because it has a frequency of 2 instead of 1. Type object. Now if you ever print the data type of df.model, it will model.describe, it will actually have a float 64 like we had. This will have object, So model has object type data type. Now, if you print the data type like type bracket df model, like we have in Python in general case, there it will show O, D type O. O is basically object. Float 64 is float 64. It will be written. So if it is ever written O, it means object. Here, that's the short form they use in outputs. This is a very specific. If you want mean 52.9980, you can just put this in like so, round, and then put whatever you want to put, like 2 or 4, whichever you want to round it off to, the number of decimal points. Df.model, like I showed you. If I run df.model, df-model.unique, it lists all the unique values. Now, if I just put Control F near, there are two instances, basically the previous one here and the next one. There are no more instances. Basically here there is only one instance of neon, although there were two, but since I'm doing unique, it's printing only once. Now let me just pause here. Any doubts? Am I going too fast, or there's a problem with my voice screen? Any doubts in the commands, technical doubts? Do tell me. If you have any doubts, feel free to share it with us. You can unmute anything. Okay, no doubts, I guess. Okay, I'll move on. If you have any doubts, put it in the chat, or you can unmute as well. I'll pause and then clear your doubt. Now, like I was saying, we have a D type like this. Now, you can have type from here. If you remove the D type and put type here, can still work. Or you put D type, which is specific to this kind of commands. See, float 64. Now, if I put model here, what will happen? I mentioned it's object, so see O. It doesn't write object, so don't get confused. It is basically over object. Now what I just did was Alt Shift down arrow or up arrow, so that just copies it. That's a shortcut to copy it. It also happens in VS Code. You can try it out. Now I'm just putting an output of type and unique is in thousands. See, NumPy. I told you it's integrated. I didn't have to put any NumPy np dot something. It just had NumPy ND array. ND array is basically n-dimensional array. NumPy is very good when you have to have n dimension of arrays. Lists we have 3D lists and all those things, but here NumPy, if you want fast processing, like I said, more the dimensions, better or more preference is given to NumPy. Type of sales, series. That's why we started with series, because it's a Panda series. Each column is like a series, and it has the index with it, referring to the whole table. So if you print just this, just like the series, it's the same kind of a thing. Length, t-type, and 0, and all those things. Now let's say I want to do operations. Now, like I mentioned in NumPy, you just need one line, n plus minus plus equal to 2. That's the same thing. You don't need loops, anything. Just put horsepower divided by engine size. Now, you can have anything. Normally, we would obviously have numerical values. So I just wanted to have, say, engine size. Yeah. If you see, I hope it's visible right here. Now, these are a few, the whole thing. So I'm not running any loop or anything. It is by default going every element wise, first with first, second with second. Now remember, there are 157 rows, so there is something. If it is not applicable, it just skips it. if there is suppose empty or empty field in engine size, it doesn't return an error, which is a very useful thing, because if you didn't have, you had 121 rows here and 157 rows here, it would be a problem. So what it does is it's normally taken as nan, not applicable, when you are basically importing it here, read CSV. So the output will also skip it. It will have nan. If you store it somewhere, it will have nan. So let me just remember, those who are doing it in editors, put print before this, like so. It will print the same thing. Okay. So what do we see here? It's the ratio. Load 64 again, length 150, length 157. Now it doesn't mean that horsepower had 157. It had 156 or less than that. Only one had 157, the first one. So rest of our in between that nan, which we'll fill up later. Now instead of that, I want to store it in the data frame, in the same data frame. The best part is you just need to write this df power to size. You don't have to do l.append in list or something like that. Just write this and print. If you put print df, you will see power to size is added, 77, all of those things. Just simple as that, one line. You don't have to even store it this somewhere. Just put it in. That shortens the code a lot, to be honest. Now just make sure, see, we have this general underscore thing, but here we didn't have underscore, it still worked. But the problem comes, suppose you want to print something like, you won't, it's obvious that you won't be able to print this df.power to size. You will be forced to put it like so, and then you put the power to size, right, like so. It is okay, it works, but there are a few commands where, or according to your wish, you may not want to use that. You want to go with something like this. For this, it basically becomes impossible to have underscore, include underscores when the original one doesn't have underscore. So what we do is we rename. Now renaming, this is the syntax. There's a general syntax. The default is false. That's why I put in place equal to true. Now the thing with false and true is in place equal to false basically means that it creates a copy. That's it. In place true means it. If I remove this, it is basically same as saying false. So in place equal to true means that same df is getting changed. Because if I do false, that's it. See, I did df.rename, but it didn't quite get changed. If I put a df, df1 equal to this, and then put something, and then I printed df1, then we can say there's a change, but not into df. So how do we change that? Basically, what you do is put this as true. Now let's print df. See, power to size. Now try doing this. Now comes the null part. Now for this, since it's a very basic thing, we are not using that column which has just 121. We are using with much lesser nans. Sorry. So just give me a moment. Okay. So we had curve weight as 155. That means there are two missing. So let's try. Let's see if we can get those. Which ones are missing? Whether we can pinpoint. Let's try this. False, false, false. It says that it's false. That means these are not null. these have some values, but we can't really, it's dot dots again, so we can't really determine whether which ones are basically there. So we try with this. Let's see what happens. It sends us the unique values. Now when you have is null is basically returning true series with true false in it. Now the true false are the only unique values, so it's basically returning false and true. By this you can know that there is something true. That means there are something, because you won't be going up and down. Here I'm showing it to you, that's why I'm going up and down. The thing with this is, it's not like you are always keeping the data by your side. You are basically coding it and then trying to find out, because there are thousands of data. You won't be able to just scroll up and find, or there may be many more columns than just 16 columns. There are many fields, there are many fields in a normal report. That's why here we say that, okay, so there are some true, that means there are some null values. Now this one also has the same effect. I just want to show that pd.isNull with df.curveWeight and df.curveWeight.isNull produces the same value. Same goes for this one. Now let's try what is the type. Let's first see what are we working on. Okay, so we are working on series. It's returning a series. Let's try shape 157. So there are 157 total entries. Done. Now comes the part. So df, like we said, we can put any index or anything. So what we are doing is we are putting a condition that df, then the rows, only those rows will be shown which have df.curve df weight dot df dot curve weight dot is null as the true condition. Because if you don't have written like is it not or is not equal to false or something like that, it's generally considered as true. So df, wherever this is true, dot shape. Now let's run this. Okay, so I need to uncomment this and then run it. So you see 17 columns because we added that power to that ratio. That's why it's 17 columns and 2. That means there are 2 values which are null, which is obvious because 157 minus 155. We could do the math easily. But just to show it technically, or when you can't do that calculation for various big numbers, so you can't. So that's 2. Dot shape gives you that. Now if you want to do 0, then it will just return 2. Now this has an advantage because you might want to just do c equal to this and then return it. That's why we need to sometimes just get the output of 2. I'm pausing a bit. Does anyone have any doubt? Anyone? So no doubts. I'm assuming there are no doubts. Let's move on then.
Vinayak, your mic is off.
Okay, I'm so sorry. Yeah. Okay, I'll just repeat. We started with this one. We had done till this much, so now we have this. This is basically printing all the rows with all the columns which have null in curve weight only, because we put curve weight only. We have NaNs, 2 NaNs right here, and this row actually has a lot of NaN if you notice this the thing. Now I just want the manufacturers who have this names in curve weight. I just put this is just like list. Like we have two-dimensional list L00 or 01, something like that. So that's basically Cadillac and Chrysler. These have the problems. These manufacturers have the problem. I can put anything. Model. Okay, now is one of the most important parts is LOC and ILOC. What is ILOC? ILOC, the way I remember it is index LOC and one is LOC, just LOC. Why index LOC? Why do I say that? Basically, when I suppose I know, okay, I want to print the 0th index column. Like remember, by default, it's the 0, 1, 2, 3, 4 other column names. So even if you have column names, you can still refer to them as 0, 1, 2, 3. Like in arrays, you don't have 0, 1 as written as keys. So when you do L0, it prints the first one. Similarly, when you do iloc, it's same. So when you do this 0, it's basically printing the first column. And index is always there. Index is not considered exactly like one of the member columns where index, it's basically considered outside. It's always present when you print something like this. Then the first column, which is manufacturer. If I know the name and not the index, I don't know if it is the first or the last. I just know it is, there is something called manufacturer here. So that's why I don't use, I have a problem. I know. I think I made a mistake. Just give me a moment. Oh, sorry. That's the thing. So the thing is that you might think that, okay, this is like dictionary. Let's just print manufacturer here. Okay. Now this obviously gives an error right here because what it does is it takes the rows first. Which rows do you want to print and then the columns. Now, if you just print it something like this, it is taking, okay, manufacturer is not any row. So why do we have this? So it's putting an error. So what I would now do is expand both the iloc and loc. So what happens with iloc is it's not just about the 0, it's also about this second parameter. Now if I do something like this, it's the same, but let's say I put something like this, 0, 0. Okay, I need to remove this. Now it's 0, 0 is similar to you saying L0, sorry, 0. Similar to that. Instead of writing it as side by side, we write it into 1. It's like compacting into 1. So 0, 0. First column, first row, Acura. Now let's say you want to print all the parts. Let's say you want to print all the parts. So you just, it's the same as this. Since you didn't mention it, by default it took like this. If you mention it also, it's fine. Say it's taking 0th row, that is this, and then it is taking like so. So when you are basically just remember like this, iloc, I index loc is basically when you know the index of what you want. You want the row, you want the column. Suppose I want this 03. Let's see what is 03. What's the value? Maybe we'll match it 16, 36. So something to do with fourth. Yeah. 0 row and 0, 1, 2, 3. 3. So 0, 3. It's like the matrix which you have. You write the row and column. So like 3, 2 is like 3 rows, 2 columns, like that. That's the same. That will help you remember what's the order, row and then column. Same for iloc. Now we know that this is the expanded form. You need row and columns. So we have same accuracy, 0. And now I don't know whether manufacturer is 0 or what it is. So we basically have 0 and manufacturer. It prints this. If I want something else, let's say, what do we have? What do we take? Model. Okay. Model is the next thing. Integra. That's the model. Like so. Remember we had this power to size thing. Now I want to print all the rows. Instead of having all the columns, now I want all the rows. So like so. See? As easy as that. So what happens is you don't need to really have different kinds of declarations in just one iloc or lock. You can just have a colon here to have all the rows, a colon here to have all the columns, like so. It's the easy part. Now I want to have this print. This is a query, because in data analysis you actually answer questions like, okay, I want this. I want to find out this value or this series or this. And when you have graphs, I want to find this graph, so I need this data, which we will be covering in next Technitude on this in this series, data visualization, where we will have data, use data, take data from log iloc, and then put it in graphs. Print all sales in thousands that are greater than mean. So personally, I actually go with lock because we don't have to know which order the columns are in. I can just write the label and we are done. That's why I personally, most of the time I use lock. Now I put a colon here and print this. Remember, you need to put something. By the way, you can't put like something like this with just a comma, or remove the comma, it will have the same error. I just returned this one. This is a list. Now I want to print something. Just okay. First, let's just print the mean. Something like this. Printing the mean. Just we had printed this before also. Now I'm storing this data frame which have values in sales in thousands greater than m. Now it's storing the whole thing like so, the whole series, but it's actually just storing the boolean values like true or false. It's showing false, false, false. I can't make sense whether there are any trues or anything. And this is basically a different series, by the way. It's not like we are storing it somewhere and then putting it. Now I want to find these values. So the thing about data frames is that I don't actually need this separate variable. I can just copy this and put the condition. Like I said, condition where it is null. Same here, we put a condition that it is greater than m. Now let's just print this. Let's see what it returns. Now this helped. This didn't give us this. Rather, it gave us the whole data frame because we put data frame with rows fulfilling this. Now we just want unique. Now you will see that this error comes up. Why? Because data frame doesn't have unique. What has unique? Series have unique. Data frames don't have unique like this. So you can't just find out which ones are, false, like we had false and true and all those things. So we can't have that. Let's try what happens with LOC. Same thing, LOC, what we did, or df.loc. Then we put the condition. These are the rows. This is the column name, because it's better to have a column, obviously. Based on, if you're doing sales in thousands, you can also have sales in thousands right here. Like so, and then just print it. So you see, these are the ones which are greater than the mean. 52 point something was the mean, so these are all greater than the means. I'm doing with respect to manufacturers. So here we have df.loc.unique. Let's try, does unique have here? Yes, it does. In fact, if you remember NumPy, it actually has the same kind of structure. See, the type object, it also has the information. Numpy arrays also have, while declaring, you can also declare d type if you want to forcefully, give it a data type. If it doesn't match at all, it will return an error, but you can do something like this while actually declaring numpy arrays. So here we got. So see, LOC is so helpful. You don't need to do all those getting the series dot unique and then all those things which we tried in that unique one. So here, if you notice, these are the unique ones, which is quite less because 157 you could see there are many repetitions here. Volvo, so many things, so many repetitions. So this is what we have. Let's say, what is the size? How many are there? Like I could just 1, 2, 3, 4. I could do this or just print this because honestly there might not be so less. So it's 17. It could have been 30 also. Okay. Now let's try what this does. Now see, here we didn't specify any condition. So it just printed the unique ones in manufacturer, by the way. This is manufacturer. So unique manufacturers where they are greater than the mean, where the sales is greater than the mean, has 17, and all the manufacturers in unique are 30. So we have 17 out of 30 manufacturers which have a sales greater than m mean. I want this value. What is the ratio? So this is a very big one. Let me just break it down. DFLOC is same thing. Now this whole thing is like a condition. Sorry, where did it go? Okay, let's skip that. This part. First, we have the condition for DF sales in thousands greater than m. Unique dot size basically 17 divided by the total number of unique manufacturers. Let's see the ratio. Sometimes the ratio is quite useful actually. So see, just one line. I had to just print this one as this one equal. If you see, it's partially highlighted just to make sure it's equal. So this is the unique with greater than mean. This is the total. No condition about greater or less, just the unique number. And we got that almost nearly half of it, half of them are like that. Follow that pattern, the greater than mean. What if we want, like, okay, so this is done. So now we want to print more than one column with LOC. We might want to see more than one column. So there we had DF comma directly without LOC we did. Now let's try with LOC what happens. See, same output. So you're having a list, you're having all columns. You can also put like zero columns. So it has a different format of showing it, manufacturer, since you're specifying. Also it's just taking the data frame. Like so. In 5 and 5. This I just showed you. Now remember the index, the default index is 0, 1, 2, 3, 4, 152, 153. Suppose you had a different index. Let's say the index was something like this. We don't really have unique values, so I didn't put any of the CSV row or columns as the index. I just put the default ones. But suppose you had anything and it was A1, A2, so you can't use 0. You can use 0, it will just take that, okay, the first row like that. But you can also go label wise there. That's the thing. You can actually use labels for rows as well. You don't have to do 0, or for the 10th row we have to put 9, do all those calculation. Okay, we need 11 to 19, so I need to put 11 to 20. All those things you don't need. If you have non-numerical things, you can just put, suppose you identify a certain record by its name, A1. If you have done SQL, you might know about primary key. That's that. So A1 is basically that. So you can use A1 if you would have put like this. Yeah, like this. Since we have 0, 1, 2, 3, 4, we are putting. So here, this is how you set the index. You have imported it. Now you set the index right here. Set index, set underscore index, manufacturer. You want to put manufacturer as the index column. What it does is, see, wait, I think I need to say, okay, it's making a copy. Okay, Okay, it makes a copy. Sorry, it makes a copy. So you df is not getting changed, but still I can just show you what it does. Accuracy, Akira became the thing. Now, ideally, it should not be because it's repeating, but this is how you do it. If you have any column that has unique code or something like that, you put unique code, that name of the column, and put it. And just if you want to go back to default, just reset. Here it would create a copy, so it doesn't matter. Still, we are doing it just to show you the commands. Okay. Now I want to print those where the column names have this value. Again, similar. We are putting conditions on non-numerical columns, on object columns. So I put like this. So where the manufacturer has Volvo. So Volvo, Volvo, Volvo. Now notice it's in order because the whole data is actually alphabetically ordered based on manufacturer. So V is last. So in order, it doesn't have to be in order. It can be anything. Now I want to print only, now it's printing all the columns. I just want to print manufacturer and sales in thousands, where manufacturer has Volvo. Since it has more than one column, it's by default printing in this format itself. Now let us take a break and tell me if you have any. You're right, that could be a value, but even if you try with the parentheses, it actually doesn't work. Because if it worked with parentheses and something, if we didn't put it, then it would have not returned that kind of error that it doesn't have any value. In fact, it is not callable. It has different error messages for that. But if it says it has no attribute, means it has no attribute like that. Like unique or unique. Basically, the difference between unique parentheses and unique is it's like calling a function just the name and just using parentheses to show that it is a function. So that's why we say that it is no attribute means it doesn't exist at all. So Kamalesh, that is answer to your query. But yes, it's good that you came up with it. Great, great. Welcome. Okay. Now let's put more than one condition. You know, and if this and this. So this is the and condition. Now let's try the first one. Let's see what happens. Mind you, there will be an error. But let me just show it because it's a very common. Sometimes it's quite common. I've seen it. See, cannot perform detect. Now you want to confuse like where is this float? For where are we like doing the converting or combining a float for 64 and a bool? So you will notice that you put df manufacturer equal to Volvo and a second condition df sales in thousands is greater than 15 in Volvo sales in thousands. You put and here, so what it does is it takes equal to Volvo and this. It's basically manufacturer has to be equal to this and this. It can't be. If you had suppose Volvo and Acura, then you would have put. So you need to put first brackets like this. This is one condition in one bracket and another condition in another bracket. So I put the parentheses. Let's see. It worked. Only those which are greater than 15 are being shown. These were the values. See, this 3 are excluded. Okay. Now we are at the end. Now I will show you something about directly modifying apart from that calculation and adding a column which we did. Let me just print this. Let's see what happens. Okay, so curve weight is null in which rows? In a certain 15 and 33, that's the index. And I'm printing the manufacturer which is corresponding, the same thing. I just copy paste the same command. It's the same thing. I put curve weight, we put the NaN. This doesn't mean you don't need this, but I'm just putting it that it's NaN. Okay. Now this is where this main thing comes. Remember, this equality is very important. When I share this, these things will be written, so you don't need to worry, and you can note it down in your files. Like we have Like I maintain a very small notebook of these notes and few very common things. I log this common fill is null these things. So what it does is it fills up those NaN values with 0 comma 0. You can now, since it's a numerical one, I'm filling up with 0 0. If it was something else, we would have filled it with ABC XYZ or see, NaN is basically like a keyword. Now this is a keyword, it identifies that it is null. But if you want to put something which actually says that none or not calculated, missing, or you want to put actually something NaN which is, it takes it as a, not as a null value, not as an empty value, but takes it as NaN. It shows that okay, there is a column NaN. That's why you need to put it. Right now it's just empty. So you put 0 comma 0 bits numerical, and let's see if yeah, it's successful. df dot curve weight equal to, this equal to has to be there, it's not changing, it's taking a copy. You need to put it inside this this column. Now not df equal to this, because see df dot curve weight dot filna, so you need to put df dot curve weight, so you, so that those two series are combined side by side element wise. I've done this. Now let's do this. Let's run same as this. See, it's so nothing, it's a series but it's empty. Manufactured, because we are putting manufactured, you can put curve weight. If you put curve weight, empty. 464 came because now we are doing curve weight. We successfully removed the empty ones. Now this is the end, but certainly data analysis doesn't stop here. Even before you start with data visualization, there are many things to be done. We will share cheat sheets at the end. Right now we are done with the hands-on session. Now, a few things before we end the session is that the cheat sheet which we mentioned will be shared in the WhatsApp and the Telegram groups. The links will be reshared right in the chat box. Join them, and we will be sharing within 24 hours. If you have any doubts, if you actually carry forward with this, you can actually like share with us what you did. There are 2 links available. Now, these are the giveaways. They are free, the free cheat sheets which we are giving. Now, when you're scanning this QR, just be sure that you're scanning it properly, because they might get overlap, and you're trying to scan Telegram, it might scan WhatsApp, and the links are also shared here, so you can obviously scroll up, and here it's right here, recently shared again. You can click on those links and join our groups. Show off your work. That's it. The best way is connecting with your seniors, telling them what you know, what you have done, and it's like a takeaway from what we did here. You can throw your own code. You can have something new. Try with the other CSV files. So this is the formal ending of the session. And if you have any doubts, please do share. If you have anything to share, anything else, any problems you faced, do tell us. And we will have a Technitude again next week. So follow our Instagram accounts, follow Facebook and LinkedIn. You could get all your updates, and also the updates will be shared on our WhatsApp and Telegram groups. We'll have another session right here, and this is a series. So we'll have data. We had data analysis with Numpy Pandas. We'll have data visualization with Matplotlib and Seaborn, which is next. So I hope you all enjoyed this session. If you have any doubts, ask, or else we'll wrap up. Thank you to everyone who attended this session. Yeah, tell me.
Yeah, I have a doubt. So
Yeah, please.
what advantages that's, I mean, we basically did over here was, what we did over here was database management, right? I mean, in this.
Yes, on a very basic level, yes.
So what are the advantages that this method possesses compared to MySQL? Because, I mean, the reason why I'm asking this question is, in 11th and 12th, I learned MySQL and also learned how to connect it with Python using the MySQL.
Good. So you have experience with using Python data analysis.
Yes. So I wondered what advantages does this possess compared to MySQL?
See, the thing is, SQL, yes, it's quite simple, but the thing is, if you begin with data analysis, if you want to start with, say, database management, relational database management, it's good if you start with SQL. But if you want to handle large amounts of data, it see, one of them is obviously the amount of data which you have now, and also with SQL, like here, what we did in Python, we had an editor, we could easily edit and we could go back and forth in the rows. It's basically right coding normal for loops and for do while loops. But SQL has a limitation. Actually, if you are considering only this technitude, it won't really help you in understanding how powerful Python is compared to SQL. But if you are going forward with this, which I would really encourage you to, since you came here, if you attended this technitude, but if you follow up, then what happens is in Python, you can have complex instructions which are quite simplified in the sense you have single lines, you don't have multiple lines, you like select star from this table where this happens. So this is, there are few separate lines, and if you make a mistake there, you have to retype. If you have the command line, if you use command line in SQL and command line, but this doesn't have in Python. You can have editors, you are free to use, and it's powerful. These are the few things. And commercially, Python is quite rising, and in fact, a few places it's the only thing or the most common thing that is used.
Okay. Yeah.
I hope I answered your doubt.
Yeah, it answered my doubt. Yeah.
Okay, great. Anyone else who has a doubt? May not be related to this very session.
Yeah,
Thank you,
actually,
guys.
I had a doubt.
Okay, sure, shoot.
Yeah, so in this session, we tried or we changed the value from NaN to 0, but is there any benefit in doing that? I mean, it's not, if even if we put it NaN, it won't matter.
Yes, what it would do is it would ignore it because it's an empty value if you are plotting anything or using it further. But sometimes what happens is that 0 0, see, I took a column and put 0 0 to it just to show, and it had only two NaNs, but it doesn't matter there. But what matters is sometimes you might have to plot like the variation in values of certain values, like variation in results. Suppose you are plotting some results of an experiment, so now it can be negative, 0, and all those things. So it can vary from negative to positive. Now if you have, now the results may be 0, the result may be 0, and 0 has a significance there, or 1 or anything, like that, okay, if you don't get any results or if the output is nothing, you mean that it is a default value of, say, 1. The experiment supposed to return 1 by default. Now the person who was taking the thing, he or she saw that, okay, no output, so empty. It happens, like it's a real world thing. Everyone has their own way of thinking, so they may skip it. Okay, no output, so let us put it 0, but 0 was important, or the default values are important, so that's why. And it will affect if you don't have the ones there, it will be biased. You are taking only a fraction of the total population, the total rows. That would create an error. It won't have technical the syntax error, but logical error for sure. It will give you wrong inputs and outputs. That's
So
why
if
we
there
have to
is, so if NaN is there, it would actually just remove the entire row from consideration.
No, there is a separate command for it. We didn't really touch upon that, but you can remove the entire row. But I won't suggest removing entire rows, because what happens is, suppose there is a NaN in row A, and there are, suppose, 10 rows total. Okay, very simple, just 10 rows in a data frame, and in A column there are first 5 are NaNs, and in B column the last 5 NaNs. If you remove NaNs, the whole data frame becomes empty. So removing it is risky. You might end up losing value, a lot of values probably. If you notice that not only that weight was NaN, there were several other things that were possibly NaN. There was one which was 121. So if you remove NaN rows, then it would remove that many, the difference, that many rows. So you can't have that. So it's better to give it a value, replace values instead of removing it. Removing it is easy if you know that, okay, what I'm losing, it doesn't matter. Else you should replace.
Okay, got it. Thank you.
You're welcome. Any more doubts? Thank you, Nimesh. Thank you, Manav, Samrit. Thank you, everyone. Thank you, Charlie.